And as we've already started discussing linear motion, you are talking about something that is moving in a straight line. Okay, please make sure that you are free to ask in case you aren't clear. So to introduce you so that you just remember what we did, say you have got this object. It has got a mass of 20 kg. And then for this object, you are pulling it forward, you are pushing it forward at a force of, let's say, 100 newtons. And you have been told that the coefficient of kinetic friction on the ground on which you are pushing this box says 0.12. And then they ask you find the acceleration of the box. So that will be number one, find the acceleration. Let's say part B, you've been asked to find the distance covered. You know distance, the symbol is S in physics, after the box moves for 2 seconds. So these are the questions. So how can we start? Starting with the first one, we want to find the acceleration. One thing you need to know is that for an object that you are pushing on a straight line, the net force acting on an object, the net force, because this is in the x direction, so you say net force in the x. You look at the force that is pushing that object in the direction where you are going. So you have got the forward force, and that forward force we call it the applied force. Minus, is there any force that is going in the opposite direction? In this case, because we've been given the coefficient of kinetic friction, that means that we have got actually friction, and that is kinetic friction. Because if the object wasn't moving, there is a force that is trying to stop it from starting to move. That is known as the static friction. So I would have used this static friction here, but this object will be moving, right? And you know from second law of motion that net force is given by mass multiplied by acceleration. And this is going to be equal to applied force. Kinetic friction is given by coefficient of kinetic friction times normal force. For an object that is on a level ground, the normal force, which is the upward force, is equal to the weight force, which is the downward force. And therefore, where there is normal force, I'm going to put mass times gravity. Are we moving together so far? Is this okay? I don't want you to get there. I want you to understand. Are you understanding or not? Are we? So the only thing we are doing is the net force. Net force is given by a forward force minus a backward force. The forward force is what you're applying. Backward force is the friction. You know friction opposes motion. So you always subtract friction. And you know that net force according to Newton's second law of motion is given by mass times acceleration. In the previous class, I gave us the formula for kinetic friction, and we said that kinetic friction is given by coefficient of kinetic friction times normal force. And because this object is on a level ground, normal force is equal to mass times gravity, which is the weight force. Is that okay? Where there is mass, we are going to substitute, that is our 20 times acceleration. Applied force is 100 minus coefficient of kinetic friction, that's 0.12. The mass is 20. Gravity is 9.8. So this is going to give us 20A is equal to 100 minus. So we can multiply 0.12 times 20 times 98. 0.12 times 20 times 9.8, not 98. That has given me 0.12 times 20 times 9.8. It has given me a 23.52. So 20A is going to be 100 minus 23, and that gives us a 76.48. To remain with the acceleration, we divide both sides by 20, and that is going to give us 3.824 meters per second squared. So that is the first part of the question. Second part of the question, we want to find the distance that is moved after 2 seconds. So we can use any one of the equations of motion. We know that distance, which is s, is equal to ut plus half at squared. So if we take it that when we are pushing this object, it started from rest, the initial velocity was 0, then we are going to say distance is equal to the initial velocity 0 times time, which is 2 seconds, plus half, acceleration is 3.824, and then time is also 2 squared. So the distance is going to be 3.8 times 2 squared, which is a 4, and then divided by 2. That is going to give us 7.648 meters. That is the distance that is going to be covered after 2 seconds. Part C of the question, we want to find the velocity, the final velocity that it is going to have. Okay, let's say after covering a distance of 5 meters. So for that one, we can use another equation of motion. 2as is equal to v squared minus u squared. This will be 2, the acceleration 3.824. The distance covered is 5, is equal to the final velocity is what we want, because we are taking it that this box started from rest, so the initial velocity is 0. And so v squared is going to be 2 multiplied by 3.824 multiplied by 5, and then that is going to be 38.24. For me to remain with velocity, we square root both sides, and so velocity is going to be equal to 6.18 meters per second. Does this make sense? Are we okay? All right. So let's talk a bit interesting stuff. Say you have got an object. It is still on a level ground, but then I apply a force like this. You know the way we used to drag. If you are a male, you should know this. The way we used to move those toys, which we used to make with bottles for maheu, you have put a camera wire on top there, and then you are pushing this bottle. Let's say it's like that. You are pushing it forward. Now let's say I'm applying a force of 200 newtons, and I'm applying this force at an angle of 30 degrees to the horizontal. Yes, please. Is that a question? Say this box has got a mass of 10 kg, or this toy has got a mass of 10 kg. The first thing we want to find, and since we are pushing it from rest, what will be the acceleration that the box is going to attain? And then B, what will be the distance covered after, say, 3 seconds? And then number C, what will be the final velocity after covering a distance of, say, 5 meters? That is our question. Again, you want to work with forces. The first part of the question, want to find the acceleration. You use net forces. Net force in the x direction is going to be equal to the forward force, and that is the forward force in the x minus any friction. For this question, we've not been given any coefficient of friction, so we are assuming that the ground is frictionless. That is important. If they've not given you friction, you take it that there is no friction, so there will be no force that you'll be subtracting. So the net force will simply be equal to the applied force. Now you can see this applied force is being applied at an angle. So you're actually going to break it into components. There's going to be a component that will be going downwards. There'll also be a component that is going forward. So there's an x component and a y component. Now you know that net force is given by mass times acceleration, and that will be equal to the x component of this force. And so this is going to be mass times acceleration is equal to x component of any force is given by force cos theta. Okay, we did this in vectors, isn't it? And then the mass here is 10 multiplied by a. The applied force is 200. Cosine the angle theta is 30 degrees. So this is going to be 10a is equal to cos 30. So we're going to say 200 cos 30. That is going to be a 173.205. The acceleration here is going to be, divide both sides, 173 over 10. That will be 17.3 meters per second squared. The second part of the question, we want to find the distance after 3 seconds. The distance moved. Okay, before we do that part, assume, for the second part I told you, assume the coefficient of kinetic friction is 0.2. What will be the acceleration? Now, if we have been given the coefficient of friction, it means that in this case, the net force in the x direction is going to be equal to the applied force in the x, but because we have got coefficient of friction, we are going to remove the what? The kinetic friction. Net force, you know, that is given by mass times acceleration. X component of the force, you know, that is given by F cos theta. Kinetic friction is given by coefficient of kinetic friction times normal force. Please, for this one, normal force is not equal to mass times gravity. Why? I said that the normal force is a force that is going upwards. That's a normal force. Look at what's a downward force. We have got a downward force here, that is weight force, which is mg. But look, we don't only have one downward force, we also have the y component of the applied force is also going in the downward direction. Therefore, for me to find the net forces which are acting in the y direction, that is going to be equal to all the upward forces. The only upward force is the normal force. Remove all the downward forces, so I've got Fy and we have got mg. Now, because this object is not moving up and down, remember net force is given by mass times acceleration. Because this object is not moving up and down, the acceleration in the y is 0. Therefore, the net force is going to be 0, and that will be equal to n minus Fy minus mg. That tells us that the normal force is going to be, I'll take these guys which are negative to the other side. So normal force is equal to Fy plus mg. So that becomes the equation for normal force. That's why in the previous class I told you to say normal force doesn't have a specific formula. It depends with the condition. So that is going to be F cos theta minus coefficient of kinetic friction times normal force. But where there's normal force, we're going to put Fy plus mg. But remember Fy, how do we find Fy? Fy is given by F sin theta. Y component is always F sin theta. And then plus mg. So in this case now the mass would have been, that is still 10 times A is equal to F is 200 cos the angle is 30 minus coefficient of friction, that is 0.2. We are multiplying that by F, which is 200, and then sin the angle is 30, and then plus the mass is 10, gravity is 9.8. Okay, like that. Since 10A is equal to 200 cos 30, that is 173.205, and then minus, we have got, so I'll first work what is inside here. 200 sin 30 is going to be 100. 10 times 9.8, that is 98. So I've got 200 times, 200 plus, sorry, 200 sine 30. Sine 30 is 1 over 2. So that will be 100. So I've got 100 plus 98. which is 198. 198 will multiply with the 0.2, which is in front. That is going to give us a 39.6. So this is going to be 10a is equal to 173.205 minus 39.6, which is going to be a 133.605. So therefore the acceleration is going to be 13.3 if you divide by 10 meters per second squared. You can see that the acceleration reduces when there is friction, because friction opposes motion. That's why there's a reduction in the acceleration. Does this make sense? Okay, good. So to find the distance, we've already talked about it after 3 seconds. Distance is equal to ut plus half at squared. Still, this object will be starting from rest, so the initial velocity is going to be 0, then plus half. The acceleration, depending with, if we are talking about the first time when there was no friction, we'll use that 17.3. We'll multiply by the time, which is the 3. We square that. And so that would be 17.3 divided by 2. 17.3 divided by 2, and then times 3 squared, which is of course a 9. That would give us a 77.85 meters. So the question C is saying, what is the velocity after 5 seconds? So say v squared is equal to u squared plus 2as. So that will be v squared is equal to, the initial velocity is 0, to the acceleration is 17.3, and then the distance is 5. So this will be v squared is equal to 2 times 17.3 times 5. That will be 173. And then we want to square root both sides to remain with v. That is going to be a 13.2 meters per second. So that would be it. Is that okay? Is there anyone that is left out? Is that okay? Okay. So let's say we have got another situation. Say you have got a box here, and then you have got a box here. Okay. So let's say this box has got a mass of 2 kg. This box has a mass of 5 kg. And then we are applying a force here, a force of, say, 20 newtons. The first part of the question is, find the acceleration of the boxes after you apply that force. And then B, find the force that, let's say this is A, this is B. So that B applies, not applies, but exerts. That's wrong English. So that B exerts on A. Okay, that's our question. So to begin with, you know that, again, you look at the net forces for part A. The net force in the x direction is equal to forward force minus friction, but there's no friction here, so just say forward force. And we know net force according to Newton's second law is mass times acceleration, and that is going to be equal to forward force. The mass, because these objects are attached together, their mass is going to be combined to find the acceleration, so that is going to be 7 times the acceleration, and that is going to be equal to 20. So the acceleration therefore is going to be 20 over 7, and that is going to be 2.86 meters per second squared. Part B of the question, we want to find the force that B is exerting on A. So what is the force that this one is exerting on this one? One thing that you need to know is this. When you are pushing a box, right? Because you are pushing on the direction of A, what will happen is that A will actually be pushing on B. So A is going to be exerting a force on B. So we can say force, Newton's second law, is equal to mass times acceleration. So we need to first find the force that the box on whose side we are exerting the force on is going to exert on the other box, because that's the direction on which we are applying the force. So what is the force that A is going to be exerting on B? So that is going to be A is exerting on B because we are moving B. So we get the mass that we are moving because we're exerting a force on B. So the mass that we're exerting a force on is a 5 newtons, 5 kg mass. The acceleration is 2.86. So that will be 2.86 times 5. That is going to be equal to 14.3 newtons. So this is the force that A is exerting on B. According to Newton's third law of motion, there's to every action there is an equal but oppositely directed reaction. So since A is exerting a positive force on B, B will also exert the same force on A but is going to be negative in sign. Therefore, the force that B is exerting on A is negative 14.3 newtons. If let's say this 20 newtons force was being applied in this direction and not on the direction of A, if we wanted to find the forces which these guys are exerting on each other, we would have still said force is equal to mass times acceleration. But in this case, the 5 kg box is pushing the 2 kg box. And when you're using the formula force is equal to mass times acceleration, you always use the mass that you are pushing, not the mass that is pushing. So if we apply the force in this direction, it means that the mass that we are pushing is a 2 kg object. Therefore, that would have been 2 the mass. The acceleration would still be the same 2.86. So this would be 2 times 2.86, and that would give us 5.72 newtons. So this would have been the force that B is exerting on A. If they asked us to find the force that A is exerting on B, we would have just taken the negative sign of this. Because the law of motion tells us to every action, there is a reaction, but that is equal in magnitude, but opposite in direction. Do we make sense here? Is this okay? Okay, good. Let me give you another example. Let's say you have got an object here. It is connected to another object via a string or cable, and then you get this second box. You are pulling it, let's say at 50 newtons. Say the first object has a mass of 10 kg, the other box has got a mass of 5 kg. And let me call this as A, this as B. You are pulling them at this force. Now you have got a question to say, find number A, the acceleration of the two boxes, number B, the tension in the cable. The tension that is going to be in this cable, because when you are pulling two things, there's going to be a tension, a force. Tension is simply a force that you find in a cable. So to do that, we are going to start with box A to find the acceleration. So for the box A, you look at the net forces of box A in the x direction. Look at the force that is pulling it in the positive direction. So for box A, the force pulling it in the positive direction is that force, which is 50 newtons. So for now, I can say that's the applied force. But what is opposing motion for box A? Because it is pulling another object, the force that it is using to pull that object will be acting as a friction, opposing motion. So that tension is going to be opposing motion when we are pulling box A. And we know that net force is given by mass times acceleration. But this mass will be for box A because that's the one that we are trying to pull. And that will be equal to applied force minus tension. The mass of box A is 10 times the acceleration, and that will be equal to applied force, which is 50 minus T. I can make T subject the formula. I'll take T this side and then 10A the other side. So that will be T is equal to 50 minus 10A. This is equation 1. We can't solve it because we have got two unknowns. Now we are going to go to the second box. This second box is also going forward because we are pulling the first box. So also look at its net forces in the X. But for the second box, the force that will be pulling it in the direction of motion will actually be the same force that is in this cable, which is the tension. That is going to be the forward force. But we don't have any backward force for that is opposing box B, unless if there was friction, but there's no friction in this case. Net force is given by mass times acceleration, but in this case it's mass B times acceleration, that will be equal to tension. The mass B is 5 times acceleration, and that will be equal to T. This will be our second equation. We have got T is equal to for the first equation, and then this one is also T is equal to. So we can equate these two equations. I'm going to say 5A is going to be equal to 50 minus 10A. I'll take the 10A this side. That will be 5A plus 10A is equal to 50. This is going to give us 15A is equal to 50. Therefore, acceleration is going to be 50 divided by 15. And acceleration is going to be 3.3 meters per second squared. This is the acceleration at which both boxes will move because they are connected. Now, the second part of the equation, we want to find the tension. You can get any one of these two equations, equation 1 or equation 2. Let me get equation 2. Tension is equal to 5A. So simply say 5 times the acceleration, which is what? The acceleration there is 3.3. So this is going to give us 16.67. Tension is a force. This is newtons. So that will be the tension in the cable. You actually do the same even when you are given three boxes connected. Does this make sense? Is this okay? Okay, let me give you now the last example, then we are done for now. Say you have got a box something like this. You have got a box on top here. This box here has got a mass of 20 kg. It's connected to another box, and this box is down here. It is hung, and this box here has got a mass of 50 kg. So the question is, what is going to be the tension in the cable, and what will be the acceleration of these objects? Let's say, for example, on this table, there is also friction. Let's say the coefficient of friction is 0.1. So you start with one object. Let's start with this object. Let's say this is object A. This is object B. Let's start with A. So for object A, if you look at the net forces, this object will be moving in the y direction. It will not be moving in the x. So because this one has got a higher mass than the one which is on the table, it means that these objects will actually be moving in this direction. Like the 50 kg will be pulling the other one. So this is going to be, what force will be pulling this object downwards? That is a weight, and that is mass times gravity. But then there's a force that is trying to pull to stop it from moving downwards. That is actually the force that is in the cable, and that is the tension. So it will be mg minus tension. Net force in the y is given by mass times acceleration. Remember, this is the mass for the object A, and this mass here is also for A, and that will be equal to MAG minus tension. The mass is 50 times A, and that will also be equal to 50. Where there is G, we are putting 9.8 minus T. I'll take T this side so it becomes positive. 50 times 9.8, that is going to be a 490. I'll get this 50A, take it this side, it becomes negative 50A. This will be equation 1. Equation 2, now we are going to be dealing with this guy here, object B. We'll also look at its net force. But this one will be moving in the X because it is on a horizontal ground. The force that will be pulling it in the forward direction is going to be the force that is in the cable, and that is still the tension. Because it is on a ground that has got coefficient of kinetic friction, it means that there is actually going to be friction there, and that will be the kinetic friction, and this one will be subtracting. Now net force, we still know that is given by mass times acceleration, but this is mass for object B, and that will be equal to tension minus, kinetic friction is given by coefficient of kinetic friction times normal force. But for this object, the only forces acting in the Y, we have got the downward force, which is the weight, and then the upward force, which is the normal force. That tells us that the normal force is actually equal to the weight force. That will be mg. Remember, this mass is for the same object B. The mass is 20 times acceleration. That will be equal to tension. Coefficient of friction is 0.1. Mass is again 20. Gravity 9.8. This is going to be 20A is equal to tension minus. So we are multiplying 0.1 times 20 times 9.8. That has given us 19.6. I'll make this up to the formula. All I would do is get the 19.6 and take it to the other side of the equation. So T will remain alone. We're going to have 20A and then plus 19.6. This will be equation 2. So since we have got T is equal to and T is equal to, equate these two equations. So this is going to be 490 minus 50A is equal to 20A plus 19.6. Put like terms together. I'm going to take the 50 this side, and then I'll get the 19.6 and take it this side. That will be 490 minus 19.6 is equal to 20A plus 50A. So 490 minus 19.6, that is going to be a 470.4, and that will be equal to 20 plus 750, that is 70. To remain with A, divide both sides by 70, and that is going to give us an acceleration of 6.72 meters. To find the tension, you can use any one of this equation. You can use this one to be 490 minus 50 times the acceleration, which is 6.72. This is going to be 490 minus 50 times 6.72. That is going to be 154 newtons. That's the tension in the code. Sometimes they can ask you to say, find the distance that this object is going to drop after, let's say, 2 seconds. So that distance is basically the height. So what will be the height it will drop after 2 seconds, assuming it started from rest? So you still say height is equal to ut plus half at squared. And so this is going to be the initial velocity is 0 because it started from rest. That will be half. We are not using gravity here. You only use g on height if the object has been freely released. But this one is not freely released. It's actually attached. It's pulling something. Okay, so we'll use the acceleration that we calculated at 6.72. The time is after, let's say, 2 seconds. So that is going to be a half, which is 0.5, times 6.72 times 2 squared, and that would have given us, it would have covered the height of 13.44 meters. So that is how you can be able to work out these questions.